Hello everyone. Today let's go over a medium question that I just solved on my own. So pretty happy about this because I originally tried this many times and got time limit exceeded. So let's go over it. So you're asked to find the longest arithmetic subsequence of a given difference. Essentially what that means is as long as the difference is what you're given here, then plus 1. So here it'd be 4 because the whole thing is a subsequence. Here it'd be 1 because there's no elements that are the difference between two elements are 1. Here, so if you go here, 7, 5, 3, 1, this is going to be minus 2. So it's a subsequence, not a subarray, so there can be elements missing in between. So the idea here is that you want to basically have an array of 1 times the length of ARR, and then you want to go from left to right or right to left. So if we have this array, we're going to have I here, and then we're going to have J here going to the left, right? So all the way until you get here, and then we're going to compare the difference to see if the current element minus whatever is equal to the difference. If that is the case, then update the position of the element to be whatever this is plus 1 because we found one more element to fill that difference in that subsequence. So for example, if 3 minus 1 or 1 minus 3 is minus 2, which it is, then we're just going to say dp of this element is whatever this element was plus 1 because we found one more element. So the length of the answer is increased by 1. So length of ARR, so from right to left, and J is going to do this. And then again, if ARR of I, the current element, minus ARRJ is equal to the difference, then dp of the pointer going down that's moving is equal to the current pointer plus 1, and then we can return max dp at the end. So this technically works, but you're going to get time limit exceeded, so we have to use a hash map to speed this up. And so what we're going to do is, I'm going to show you in a second. So the way that I came up with is to use a dictionary of list, because we want to first enumerate ARR. We want to basically get all the values and where they occur in the indices. So now you're just going to have 1 at 0, 1, 2, 3, and then at each turn, what you're going to do is you're going to take the current value, right? Because we basically want to say, okay, we want a hash map of the values and where they appear in the indices up to this point. When i's here, then we only want the hash map to go from the left up to this point. So you're going to have value of 1 as a key, value of 2 as a key, and then the indices that they appear, 0 and 1, as the values to those keys. So for example, if you have a hash map here, you can say 1 is at 0, 2 is at 1, 3 is at 2, and then this is when the current element is 4, right? And then what you're going to do is you're going to find the difference, because if we want to say the current element minus whatever is the difference, then we're just going to look for the current element minus the difference inside of our hash map, because 4 minus 1 is 3, and if 3 exists, then we're just going to take whatever indices 3 appears at and update that to be dp of I plus 1 instead, because the values are the keys in the dictionary now. So now, and the way we're going to shrink the dictionary to basically eliminate this is because for this, for example, we're just going to pop, and then if there's nothing in it, we're going to delete it. So now this is everything up to this point in terms of values and indices those values appear at. So we're going to say dcur.pop, right? So doing this, for example, and then we're just going to say if not dcur, then delete dcur, delete that key value pair from the dictionary entirely as with this example. For example, there's nothing inside of this list, so just delete it. And then now we can say the difference is going to be current minus difference, right? So 4 minus 1, we're looking for 3 as a key in our dictionary. In this case it is, so then we're just going to loop through every single element in the value of that key and update the DP array, just like we did before. So for A in D of difference, dp of A equals dp of I, which is the current index, plus 1, because we found one more element. It's a subsequence, right? So the result would be increased by 1. And then at the end, we can return maximum of dp. So the time complexity is a little better, and although it is really slow, it doesn't beat many people. Again, this is my own solution that I came up with, so pretty proud of that. And it gets over time limit exceeded. So hopefully this was not too confusing. And if you enjoyed, please consider subscribing and stay tuned for more. Thank you for watching.